Hi everyone. In this video we're going to be looking at how to solve trigonometric equations, and in this example we're going to be solving for theta but only over the interval 0 to 2 pi. So let's get started. We have 2 sine squared theta equals 1. And remember, we're looking for theta, so I'm going to start to get theta by itself by dividing each side by 2. So I need to know, where does sine squared theta equal 1/2? Well, let's take the square root, and that would be when sine theta equals, oh, don't forget, when we take the square root we get 2 answers here. We're going to get plus or minus 1 over root 2. Okay, so sine is going to be positive and negative 1 over root 2. Well, that means we're going to look in all 4 quadrants. So the first quadrant, if sine is 1 over root 2, that means that opposite is 1, hypotenuse is root 2. The adjacent side would then be 1, and we are looking at an isosceles triangle. So I know that this angle right here is 45 degrees. So my first answer is pi over 4. But like I said, we're looking for sine being positive or negative, so we're going to be looking in all 4 quadrants. So our second answer is going to be 3 pi over 4. Our third answer is 5 pi over 4. And our last answer is going to be 7 pi over 4. And again, we only have 4 answers because we're solving over the interval 0 to 2 pi. So we're limited between those 2 values. So for our next example, this time we're going to be solving for all values of theta. So we're still going to look for answers between 0 and 2 pi, but then remember that sine and cosine are periodic functions. So if we get an answer in one of the quadrants, we know that 2 pi later, and in fact multiples of 2 pi later, we're going to have more solutions. So our equation here is 3 sine theta plus cos squared theta equals negative 3. We have sine and cosine in this equation. So whenever that happens, your goal is to try to get all sines or all cosines. We have cosine squared theta, which reminds me of the identity that we learned in the previous video, where cos squared theta equals 1 minus sine squared theta. So I can substitute into this equation, and that way I'd have all sine thetas. That's good news. So we'll keep our 3 sine theta. Let's do our substitution here with 1 minus sine squared theta, and that's going to equal negative 3. So we have sine squared thetas and sine thetas. So here, I'm just going to reorganize things so that it looks more like a quadratic function that we're used to factoring. So if I just shifted everything over to the other side here, I'd get sine squared theta minus 3 sine theta, let's see, minus 4 equals 0. Now if you're not comfortable with factoring that, think about maybe doing some substitution. If you let u equal sine theta, this really says u squared minus 3u minus 4 equals 0. And then you should be comfortable factoring that, which would be u minus 4 times u plus 1. And then we can put the sine theta back in place for the u. Like that. If you feel comfortable going from here to here without doing that u substitution, please feel free to do that. Okay, so now we have 2 factors when they're multiplied equal 0, which means that we're going to set each factor equal to 0. And then solve for theta. So the first one, we get sine theta equals 4. Well, the maximum value of sine of anything is 1, so we can't get any answers from that. Okay, over here, when would sine theta equal -1? Well, if I just draw a quick little sine graph, here's the y value of -1. That occurs at 3 pi over 2. So that's the only place it occurs within one period. So that means my answer is going to be 3 pi over 2, but every period, right? So sine repeats every 2 pi, so I'm going to add 2 pi n, where n is an integer, to represent all of those answers. All right, good luck trying some of these on your own.